Often we need to work out the initial components of a velocity when an object is doing projectile motion. So it's following this arc structure or this arc pattern. From the top of a cliff, it might be following a slightly different pattern. But it's generally this parabolic motion. So here we've got an up motion coming to rest in this direction, and then a downward motion. Okay. So here we're looking at working out what are the initial components of this velocity. So we're given a velocity, say 40 meters per second. Now this is at an angle, and we're usually given that angle, say we'll make it 45 for argument's sake. And we need to find that we can't just use this velocity in order to do our calculations. We need to split it into its components in the vertical direction and in the horizontal direction. So this is the components of this. If you remember in vector addition, these two vectors produce our third vector. That one's a bit long, should be roughly there. And this is the one we're given. Now we need these two to do some of our calculations, because the motion, as we saw, as we've seen in experiments, the motion is these two separate components are independent of each other. We only have acceleration in this direction, and it's a deceleration against the object. In this direction we have a constant velocity. Okay, so we'll just get rid of that. So how do we do this? We're basically using trigonometry, so nothing hard about it. We've created a small triangle here. Okay, and we've got our hypotenuse, and we've got our opposite, and we've got our adjacent. We've got our angle here, and we've got the hypotenuse for the velocity. So what we're going to use is simple triangles. So we want to find this direction first. We've got the angle, and we've got 40 meters per second here. So if we do sine of 45, we get opposite over hypotenuse. Remember, we've got SOHCAHTOA, I think it was. Sine is cos is tan is. If we rearrange this, times this side by 40, times this side by 40, we get uy on its own over here equals, and this side here, 40 sine 45. And that's our initial component in the y direction, this one up here. For the other one, we use cos. So it's cos of that angle equals adjacent, which is our ux value. Okay, divided by our hypotenuse. If we rearrange this, we want to put this side over here. They cancel, because this one divided by this one. Remember, if you see a number on its own like that, it's pretty much that. Number divided by 1. These two cancel, so we get ux equals 40 cos 45. And there's our other one, our horizontal component. This one we use often if we're looking for a final velocity. It'll be the same as the beginning velocity. We've got time. That's the time of flight, and so we can use that velocity. And we can use these values, ux and uy, in all of the other formulas. So they're very important to be able to do this.